Okay, I had some questions from page 92, so I'll do a few problems here. The first one is like number 23. When you have a quantity to an exponent, first of all you want to simplify the inside of the parenthesis here. I cannot add these two things because they're not like terms, but that negative exponent has to be dealt with. So the first step would be to write this as x plus 1 over y squared. I'm still going to keep the outside exponent as is for a minute. Before I deal with the outside exponent, I need to get this to be one term. So let's add these two different pieces. I need common denominators. We'll put a 1 under here first. And what would be the common denominator? Hopefully you're thinking y squared. So I need to multiply this part by y squared over y squared. And when I do that, y squared, I get y squared x over y squared plus 1 over y squared. I still have the whole thing to the negative 1. All right, what do I do next? Add like terms. So instead of calling that y squared x, I'm going to write it xy squared. I just feel like I like it better written that way. Plus 1, I can add the tops, and now I just have one bottom, y squared. The whole thing is still to the exponent negative 1. Now, what I can do is I can invert this fraction, which we learned how to do this last year. Basically, I can write it as y squared over x y squared plus 1 all to the positive 1. And if it's to the positive 1, now I can just write it like this, y squared over x y squared plus 1. There's nothing else I can do here. Hopefully you don't try to cancel out that y squared, because this bottom is a quantity and you can't separate any part of it out. If I could factor the bottom, I could reduce something with the top. So there's the first one done. All right, let me take a second to clean my board. All right, this next problem. This x to the negative 4, I can move to the bottom of the fraction. So I can rewrite this as 1 over y squared x to the positive 4. Notice I didn't move the y squared because that has a positive exponent. Times this negative 1 goes to both of these exponents, so I could write it x negative 2, y negative 2, and then I could flip it over. Or a negative exponent means you can just take the fraction inside, we learned this last year, and flip it over and then change that exponent from negative to positive. So now I'm going to rewrite this so that it's a little easier to look at. 1 times y is y. Oh, this exponent 1, y to the first power is y, and x to the squared to the first power is x squared. So maybe I should write that step first. So I have 1 over y squared x to the fourth times y over x squared. And then I'm going to multiply the bottom. So I get y squared x to the 6th. 1 times y is y. Now I can reduce. Do you see what I can reduce? This y with this. So what do I write as an answer? Do I still have a fraction? There's nothing left on top. You know I do. What do I put there? Well, 1, I hope you realize that. Y times x to the 6th. So there you go for 2 examples like number 23. Okay, this one's like number 33. And the reason 33 was probably puzzling was, if you look at it, there's a radical in the top, and there's really nothing you can do to reduce that. But if the textbook wants you to rationalize the top, they mean they don't want a radical left in the top. So this is a bit unusual considering we never left radicals in the bottom, but sometimes in Precalc you have to do that. So let's see if we can do that. So to rationalize the top, I would multiply by its conjugate. Do you remember what the conjugate would be? Sure you do. From last year, this would be root 5 plus 3 over root 5 plus 3. So again, I'm multiplying the original fraction by a fraction, but this fraction has the value of 1. And multiplying anything by the value of 1 doesn't change it. We're just making it look different. So when I multiply that, the bottom, I'm not going to multiply that through. I'm just going to leave it in factored form, which is always a good first step, okay? Now, when I multiply the top, the reason I used the conjugate was the middle term disappears. So root 5 times root 5 is 5. Minus 3 root 5 plus 3 root 5 disappears, so I'm not even going to write it down. Minus 3 times plus 3 is minus 9. So there's the answer. Let's simplify it a little bit. 5 minus 9, negative 4 over 2, and root 5 plus root 3 is on the bottom. And I can't leave that answer because I see some reducing. Do you see some reducing that can happen? Hopefully, the 2 into the 4. So negative 2 on top, and root 5 plus root 3 on the bottom. I like to leave it in a parenthesis. You don't have to. And there is the final answer. Sometimes the final answer will have negative in front of the fraction and then just the 2 on top. So good luck with number 33. Okay, this next problem looks kind of scary, but just remember the rules of exponents. If the bases are the same, add the exponents. For example, if I gave you x squared times x to the third, you would know that the answer is x to the fifth. The bases were the same, so you add the exponents. If I gave you x squared times y to the third, you would just say x squared y to the third. So you need to know your exponent rules, and you need to recognize when bases are the same. The bases are the same here. So that means my answer is going to be x minus 3 to some exponent, which is the sum of these two. Oh, let's make this a little more difficult. We're going to make that one a minus exponent. So I'm going to put a little think balloon here. I have to do 1/2 plus negative 1/5. Oh boy, how do I do that? Well, common denominators, right? So 1/2 plus negative 1/5. Change the common denominator would be 10, right? So 5/2 plus a negative, 5/10, excuse me, plus a negative 2/10, which would be 3/10. So the exponent here, x minus 3 to the exponent, 3/10. And that's as far as I can go. Now you do remember that if I wanted to put this into radical form, that's the root. So I could put it as the 10th root of x minus 3 to the third. But the answer book wants it in this form here. So, but I just wanted a little memory refresher from last year. All right, good luck.